Hi, I'm Mr. Green here. I'm going to be taking you through the first lesson of topic 3 of physics, which is particle theory. First lesson today is density, and your learning objective is to use the density equation. If you could pause the video whilst you write that down as your learning objective. Okay, so as always, we'll start with a retrieval practice. There's some here that you may struggle with a little bit because we're just pushing on there, but a lot of it's from year 9. So if you could pause the video whilst you answer those 5 questions. Okay then, so question 1. What is mass measured in? Mass is measured in kilograms. Unless it's explicitly stated in the question that you're answering, you always assume that mass is measured in kilograms. Question 2, what's volume measured in? So volume is the amount of space something takes up, not the area, the full amount of 3D space something takes up. So as it's in 3 dimensions, it's measured in meters cubed, m with a small 3. Again, it may be centimeters cubed. Have a check of the question that you're doing. Question 3, how can we calculate the volume of a cube? So a cube's got 3 sides, height, length and width. To calculate the volume, it's length times height times width. Question 4. What do balloons filled with helium do? I'm sure we've all had parties where this is happening, little birthday parties. If you let go of that balloon, it's going to float up into the air. And why do helium balloons do this? It's going to be a crux of part of our lesson today, but I wanted to see if anyone knew. Helium balloons float because helium is less dense than the air. And density has got a big push over whether something floats or whether something sinks. Okay, today's lesson objectives are to state and explain the properties called volume, density and mass, and to apply the density equation to calculate different properties of certain objects. Please pause the video while you get those down. Okay, so what is density? Well, if we look at these 3 materials, we've got wood, water and iron. They've each got the same volume. They're all 1 centimetre cubed, 1 centimetre long by 1 centimetre high by 1 centimetre wide. But they all weigh different amounts. 1 centimetre cubed of wood is 0.5 grams, 1 centimetre cubed of water is 1 gram, and 1 centimetre of iron is 8 grams. Now the question first one says, which of these blocks weighs the most? You can see very easily from there which one weighs the most, the iron of 8 grams. But which is the most dense and why? Pause the video while you answer that one. Okay, so the iron block with the most mass is also the most dense. This is because it's got the most mass per centimetre cubed. Each centimetre cubed of iron will contain more mass, more kilograms or more grams than wood or water. And this is essentially what density is. If we look at these 3 images, solids, liquids and gases, we've got gas on the left, liquid in the middle, solid on the right. Which one do you think is the most dense and why? And in your answer, use the keywords volume and mass. Think about those 3 we've looked at previously. Pause the video whilst you answer this one. Okay, well the most dense would be the solid. It's because the particles in the solid are closest together. To make it more scientific and to give us those keywords we were looking at, there is more mass in a smaller volume. So there are more particles present in much smaller space than present for the gas, which means it is a higher density. This being physics, there is an equation for calculating density, and that equation appears on the board there. We use the word for density, the symbol for density is the Greek letter rho, which looks like a slanted P. That's the Greek letter for density. We don't use D for density. In science, generally, we don't do that. That's density. M is equal to mass, and V is volume. So density is equal to mass divided by volume. How much something weighs divided by how much space that object takes up. Bigger the mass, the smaller the volume, the higher the density. Looking at that then, what would the units of density be? We've got kilograms divided by meters cubed, kilograms per meter cubed. If mass is given in grams and volume in centimetres cubed, density would be grams per centimetre cubed. So be careful of the units. Look at what they give you and what you're calculating. So let's look at a quick example. So if we're given a material that's got a mass of 100 kilograms and a volume of 5 metres cubed, what would the density of that material be? Please pause the video, grab hold of a calculator and calculate the density for me there. Remember, density is mass over volume. Okay, so given this density is mass divided by volume, the mass is 100 kilograms, the volume is 5 metres cubed, the density of the material would therefore be 20 kilograms per metre cubed. 100 divided by 5 gives us 20 kilograms over metres cubed, kilograms per metre cubed. Calculating the volume of a cube or a cuboid is simple. We just multiply its length by its width by its height. So if we're given a material that's got square sides and is a cuboid, we can easily work out the volume. Also given to you there are the calculations or the ways of working out volume of a cylinder and the volume of a sphere. You'll come across these in maths anyway, and they may be useful in science. Next lesson we'll look at using an experiment to calculate density, and these will become more useful then. Okay, so quick examples for each one. If you could use your equation, you may need to rearrange it to answer these 3 questions. Get your calculator and calculate them. Pause the video now and restart them when you'd like the answers. Okay, number 1 then. A piece of metal weighs 40 grams and a volume of 4 centimetres cubed. What's its density? Density is mass over volume, so that would be 40 divided by 4, giving us a density of 10. But look at the units. Grams per centimetre cubed. That's what I was given. That's what I'm going to keep them in for the moment. Number 2, a piece of metal's got a density of 22 kilograms per centimetre cubed and a volume of 3. What's its mass? Well, density is mass over volume, so if we rearrange that, mass equals density times volume. Mass is 22, volume's 3, so 22 times 3 gives us 66. That's in mass, so we give it as kilograms. See, the density was given as kilograms per centimetre cubed. Finally, a piece of copper's got a density of 9 grams per centimetre cubed and mass of 135 grams. What's its volume? So density is mass over volume. Rearrange that. Volume is density divided by mass. Volume is 9 divided by 135, giving us 0.06 centimetres cubed. Some more questions to attempt there, so if you could pause the video whilst you attempt those. Above I've given you the calculation calendar, the equation triangle. Again, if you cover whichever one you want, you'll get the equation there. Okay, give yourself 5 minutes and unpause when you'd like the answers. Okay then, question 1. It's 4 grams per centimetre cubed. Question 2. 5 grams per centimetre cubed. Question 3, 4 centimetres cubed. Question 4, 2,700 kilograms per metre cubed. And question 5, 0.02 metres cubed. Okay, another 5 for us to do here. Again, pause the video, use the equation triangle if you need, and unpause it when you'd like the answers. Okay, question A, the answer is 13.6 kilograms. Question 7, the answer is 156 kilograms. Question 8, the answer is 1.8 grams per centimetre cubed. It asks for that in the question. Question 9, the mass is 7.7 kilograms, or 7,700 grams would be acceptable. And question 10A, the volume of the stone is 40 centimetres cubed, and the density is 2 grams per centimetre cubed. Again, this will become more important when we do our next lesson on the experimental procedure. Okay, floating and sinking. What happens to the 2 different blocks and why? Well, the first block's got a density of 0.9, the second one a density of 1.1, and the water's got a density of 1. Let's see what happens. One with a density of 0.9 floats. One with a density of 1.1 sinks. If an object has a higher density than the liquid it is put in, then it will sink. If an object has a lower density than the liquid it's put in, then it will float. Please pause the video, copy those down and put the correct answer in there. Okay, let's have a look at this problem here. We've got both Coke cans here, Coca-Cola and Diet Coke. Both of them are 330 millilitres. Coke contains carbonated water and sugar. There's more atoms in the same size area in regular Coke due to the sugar. The Diet Coke doesn't have the sugar. So on the left, you see the Diet Coke. On the right, you see the Coke. If I place, which one's more dense, sorry? We see the Coke is more dense than the Diet Coke. If I place the Coke in, it sinks. It's more dense than water. If I put the Diet Coke in, it floats. It's less dense than water. So how about floating ships? The average mass of a cruise ship is 50,000 tonnes. How does it float on water? It's called Archimedes Principle. A body totally or partially immersed in a fluid is subject to an upward force equal in magnitude to the weight of fluid it displaces. There's something showing it there. So that's displacing the amount of water underneath it, and that's pushing it up with a force that's equal. So a ship displaces an equal amount of water as it submerges into the water. That displaced water pushes back against the ship and keeps it afloat. Now, to stay afloat, the ship has to displace the weight in water before it's submerged, so before it completely goes under. It's easier if the ship's constructed in a way which makes it less dense than the water below it. So for this reason, a lot of ships have a lot of air trapped in the bottom of them. Once you trap air in the base of the ship, it makes it less dense. Quick progress check. What happens to particles as water freezes? If we look at that diagram, what's the ice doing? The ice is floating on top. So when the water freezes, the molecules arrange themselves into a rigid, ordered fashion. This means the molecules in ice are further apart than if they're in liquid form. Now that's counterintuitive. Normally in solid form, molecules are brought closer together. Ice floats on water because it is less dense. The water displaced by the ice provides a buoyant force to the cubes. And another aspect of this is that the ice also has air trapped in it, which makes it less dense than water. Okay, to finish off, we have multiple choice. If you could pause the video whilst you attempt these questions. Okay then, question 1. Density is calculated using which equation? A, volume over mass, B, mass over volume, or C, mass times volume? Correct answer here is B, mass divided by volume. Question 2. The units for density are they kilogram centimetres cubed, centimetres cubed per kilogram, or kilogram per centimetre cubed? It's kilogram per centimetre cubed, C. Question 3. The state of matter with the highest density is A, solid, B, liquid, or C, gas. Highest density would be the solid particles closest together. Question 4. The state of matter with the lowest density is that solid, liquid, or gas? That would be gas. It's where the particles are furthest apart. And finally, an object will float if it is less dense than the fluid it's in, it is more dense than the fluid it's in, or it has more mass than the fluid it's in. The correct answer in this case is A. Objects will float if they are less dense than the fluid they're in. Use of the word fluid there is deliberate. Things can float in gases or liquids. A fluid is a material where the particles can move, so we refer to those as fluids. Okay, that's the end of this lesson. Hope it was useful. If you need to review it, please watch the video again, and I hope you found it helpful. Thanks a lot. See you soon. Goodbye.